Okay, so starting with trigonometry, we're just going to look at the primary trig ratios and then angles in standard position. We're going to start looking at radians as well, but we're not going to do that in these first few notes. I'll make an alternative note for that will talk about how to go through radians, from radians to degrees and back to radians. And then we'll probably start talking mostly in radians throughout the rest of the unit. There is just a couple of applications that you need to be in radians, so it is important to know how to use them. First, if we were looking at angle A, so we're looking at that top angle, our primary trig ratios are always based around that. Now, when we're finding them, I almost always am going to tell you, if you don't know where your ratios are, you need to label your triangle OA and H. Okay, always across from the right angle is H, across from the angle we're talking about is O, and then the other side has to be A because there's only 3 sides. Then we're going to just look at SOHCAHTOA. Okay, so everyone kind of laughs when they first hear it, but then everyone writes it and uses it all the time. So SOHCAHTOA, we have opposite over hypotenuse, we have adjacent over hypotenuse, and then opposite over adjacent. Okay, and those are our basic trig ratios that we'll use for any right angle triangle. Angle of elevation is always the angle measured above between the horizontal, or up between the horizontal and the line of sight. So you draw a horizontal line out and then measure up. Angle of depression is always the angle measured down, and it's always from the horizontal. Okay, either up or down. Let's just do a few examples here. So solve triangle QRS, where angle Q is 90 degrees. So almost all of my triangles will look the exact same. So QRS, we know that angle Q is 90, so label that in there. Angle R is 42 degrees. And side Q is 10.5. And that's centimeters. So the first thing that we're going to do is just find angle S. Let's do S. So angle S is just going to be 180 minus 90 minus 42. And you can probably leave that step out and just write 48 degrees. We're going to use R to find our other 2 lengths, just because it's already given. We don't want to use something in case we wrote like 58 by accident, had the wrong angle down. So I need to find side R and side S. So I'm going to find side S first. So that's adjacent over hypotenuse. So I'm going to use cos 42 equals S over 10.5. Then S equals 10.5 cos 42, and our S value is going to be cos 42 times 10.5, 7.8, and that's centimeters. Now I'm going to just go right back and find R using sine. So sine 42 equals R over 10.5, opposite over hypotenuse. So then we get R equals 10.5 sine 42. And sine 42 times 10.5 gives us 7.02 or 7.0 centimeters. Okay, so we've solved our triangle because we have all of our sides and all of our angles. So we're all done there. In this one, it says find theta to the nearest degree. Now, the first thing we have to realize is when we're doing something like this, we have to find something common between these triangles. Now, the common thing here is going to be D and B are the exact same value. So we know in ACD, the triangle ACD, we can find angle A is 20 degrees if we wanted to. That's not really going to help us. We need to find side D. Okay, now side D is opposite, and we have hypotenuse. So opposite over hypotenuse is going to give us sine 70 equals D over 10. d equals 10 sine 70, or 10 times sine 70 if you want to write it like that. It doesn't really matter. You can write it either way. They're both equally correct. And we get 9.4. We'll just round to one decimal here. 9.4 meters. Now, we know, I'm leaving that number in my calculator because we know that D equals B, therefore B equals 9.4 meters. And now we need to find theta. I'll change colors here. We need to find theta. And we know we have adjacent and hypotenuse. So we're going to say cos theta equals adjacent over hypotenuse, so 9 over 9.4. So then we have theta equals the cos inverse of 9 over 9.4. And we get theta to be equal to second cos inverse 16.7. So 16.7, and that's in degrees. So what we're going to say is therefore theta equals 17 degrees. We're always going to round to the nearest degree, and if it's not said, to the 10th when we're finding a length. Okay. Last question. This is kind of a basic question in trigonometry. It's almost asked in any type of basic trigonometry word problem. So best thing for a question like this is to draw a nice big diagram. Okay, and then we can do it in a couple of parts when we're solving, but we've got two office buildings. There's some distance apart. The top one, it gives an angle of elevation from the top of the shoulder to the top and bottom. So what it kind of looks like is this. Office building 1, office building 2. We've got this distance. So the distance they are apart is 42.3 meters. And whether I measure on the ground or at the top of a building, it's still the same. Then we've got the distance of the line of sight up and the line of sight down. Now we're measuring our angle of elevation and angle of depression from that horizontal. So the elevation is going to be 27.5 degrees. And the depression is 78.2 degrees. Now, a lot of people will mess up and put the angle of depression over here. So you have to be careful to always go from the horizontal. Now, really quick to solve this, I'm just going to call this x and this, not x, that y. So then we're going to have, most word problems actually do use tan more often than not. Here we've got opposite over adjacent in both cases. So the top triangle is going to be tan 27.5 equals x over 42.3. X equals 42.3 tan 27.5. And then we're going to get x to be equal to 22.01, so 22.0 meters. Now we're going to do the exact same thing on the bottom for y, because it's still opposite and adjacent. So y over 42.3. Y equals 42.3 tan 78.2. Now we're just putting in those numbers to our calculator. It's really important to be used to your calculator when you're dealing with these. Okay, I can't stress that enough, that you need to know how to use your own calculator when you're doing this, because otherwise you will struggle. So this is 202.5. So y is actually the height of this building. So then we can say, therefore, the buildings, because it's a word problem, are 202.5 meters. And then we have to add those two numbers together, and 224.5 meters tall. Okay? Now the second part of this note is angles in standard position. So angles in standard position are just talking about when we're looking at an actual angle, or we're looking at how it's related. Trig ratios can actually be solved in multiple different ways. So we need to know where an angle is or where it can lie. We're going to talk a lot about the relative acute or related acute angle, the principal angle, and then the quadrants. So whenever we're labeling something like this point at the top here can always be x, y, which means we've gone over x and then we've gone up y. It's a right angle triangle. Okay, so we then can use r as our radius, and r is always going to be a positive value. The reason that r is always positive is because we're going to have x squared plus y squared equals r squared. So whether or not x and y are positive or negative, they're going to become positive. If it's -6, it's becoming +6. So positive 36. If it's -5, it's becoming positive 25. R is always going to be a positive value because it's just a scalar. Okay, so when we're rewriting our trig ratios here, sine is going to be opposite over hypotenuse. So we've got y over r. Cos is x over r. And tan is y over x. Now, this is really important for later in the unit, or actually in the next unit when we do trig identities, but you do need to understand kind of what we're talking about here. We've got y over r, so sine is y over r, cos is x over r, and tan is y over x, right? Most of the time you can actually just find the triangle after we know where it is, but that is a little bit helpful, okay? And then the quadrants, 1, 2, 3, 4, okay? So if the terminal arm lies in one of these quadrants, we're able to use our related acute angle, which if I went down to, say, quadrant 3, this angle and this angle are going to be the same, okay? So we're going to use our R value and things like that to actually find out what the angles are. So with that being said, let's go back here really quick. If we know we can find our related acute angles, if we always look at the positive value, we can find a related acute angle. So if I went over here, I would have a -x in quadrant 2 and a positive y. But if I made them both positive, it would just give me the same angle as though I was in quadrant 1. But all I'm going to do in this quadrant is 180 minus the related acute angle, and that will give me the principal angle. In quadrant 3, the principal angle is equal to 180 plus the related acute angle. Okay, we're adding that related acute angle onto 180 degrees, which would get me over to the axis again. And then finally, if I was down here, we would just do 360 minus that related acute angle to find the principal. Okay, now this is going to be helpful when we're solving trig ratios or solving equations. So find sine, cos, and tan and the principal angle given the point P if the terminal arm is in standard position. So what this is telling me is that this is in quadrant 1. We have positive, positive. So we've got 7, we've got 24. So we're in quadrant 1. So sine, cos, and tan, first we need to find r. R is going to be the square root of 7 squared plus 24 squared. So 7 squared is 49. So we've got 49 plus 24 squared, which is 576. So we're going to get the square root of 625. And we get 25 for our r. So then sine, so we can write our 25 in if we want to. Sine is going to be 24 over 25. Cos is going to be 7 over 25. And tan is going to be 24 over 7. And we can choose any of these to find our principal angle in this case, because our related acute angle and our principal angle are equal to the same thing because we're in quadrant 1. Okay, theta is in quadrant 1. So we're going to have principal angle equals the sine inverse of 24 over 25, which equals, so we've got 24 divided by 25, and we're just doing the sine inverse, and we get 73.7, which is 74 degrees. Okay, so looking at the next one. The next one's a little bit harder, just because of where it is. So the next one, we have negative, negative, so that means we're down here. Okay, so we've got -3 and 9. Okay, now notice I've made them positive. My r value is going to be the square root of 9 squared plus 3 squared. You could make them negative, but it doesn't really matter because they're both going to become positive anyways. So that's going to be the square root of 90. Now, the square root of 90, we could reduce that down if we wanted to 3 root 10. Because some calculators do it and some don't, I'm not going to get too bent out of shape about this. You should know how to rationalize and reduce a radical, but because some calculators do it and some don't, we won't test on that. So what we're looking at here, then we've got our 3 trig ratios. We've got to do sine, so remember the angle is going to be there. So we're 9 over root 90. Cos is going to be 3 over root 90. And tan is going to be 9 over 3, or just equal to 3. Okay, that one's probably going to be our easiest one to use. So what we have to recognize here is that we're finding our related acute angle first, or relative acute angle first, because we're going to find out what this angle is. That angle just in the corner there. Okay, then we're going to take that angle and add it to 180. All right, so if we take that tan, what we know about sine, cos, and tan here? Well, we know that this was negative. We know that this was negative, but we know that 2 negatives is going to make a positive. So tan is actually positive in this case. But when we're dealing with this, regardless of which one you choose, you want to use the positive values of all of them. Okay, because that way we know we're not going to get a negative number or anything, and we can just push plus 180 at the end. It will give us our answer. So here we've got the the inverse of 3. So tan inverse of 3 gives us 71.5 or 72 degrees. And therefore our principal angle is going to be 180 plus 72. So 180 plus 72 is 252. Okay. And then finally, the last one here, we're in quadrant 4. So we're down here. I'm not going to go through and write, actually we will. So here we've got 10, 5. So we need to find our r value, which is the square root of 5 squared plus 10 squared, which is root 125. Again, you could reduce this down to what? 5 root 5, but we're going to leave it as it is because some calculators do it and some don't. So sine theta is going to be 5 over root 125. Cos theta is going to be 10 over root 125. And tan theta is going to be 5 over 10, or 1/2. Now this one's negative here, and this one's negative here. Okay, we're still looking at the signs because we're going down 5. where here we have the negatives on the 3 and the 9. Okay, so we do need to know those signs. We're going to talk about that later. There's an easy way to memorize that, but you should know those. Okay, so the related acute angle right in there, we're going to use tan again, just the easiest one. It's going to be the tan inverse of 1/2, because I want to find the positive value. If I did the tan inverse of -1/2, I would get, in this case, I'm going to get the same thing, I think. 1 divided by 2, and do the tan inverse. I get -26. I want to get the positive 26 version. The reason I want positive 26 is because I want to have a related acute angle. I don't want to have to worry about adding or subtracting. I want to know what my number is. Now here, my principal angle, is just going to be 360 minus that away. 360 would take me all the way around. I want to minus away that little chunk, that related acute angle. So I'm going to do 360 minus 26. It's actually 26.5, so let's make that 27. So 360 minus 27, and then we're going to get 333. Okay. So here are your questions. This is the first part. This is the second part. If you see the answers and it says between 0 and